Guys, welcome to another video. My name is Dikarabo. If you want to know more about me, I think there's a video that covers that. On this particular episode or this particular video, I'm just going to introduce you to computer programming. So the previous video, we were talking about the history of computers, what a computer is and all of that. So here I'm just jumping straight to what is programming. So if you are ready, let's get into it. So computer programming is the process of accomplishing a specific computing result or to perform a particular computation, usually by designing or building an executable program. So that's what you call computer programming is. So the keywords there is actually computer programming is a process. So on the process, what is involved is actually analysis, developing understanding, generating algorithms, verification of requirements of an algorithm, and thereof. So I think to give more details, this is Google. I just Googled what is computer programming, and I found this particular image to have a lot more, in-depth description of this. So what normally happens is a programmer would come in, or a person who actually does computer programming would be given a set requirement to say, we want a program that does A, B, and C. So A, B, and C, for example, could be a simple calculator where you are adding a number to another number. Say, for example, 1 plus 1 equals, then the computation will then derive an answer, and the answer would be 2. 2 times 5, say, for example, when you click on the equals to on the calculator, it will then give you 10. So more or less, that's what you call executing a program would entail or give you in terms of results. So yeah, that's that. And now jumping into more details with regards to history. History is very important. It teaches us where things are, and it helps us appreciate where we are at the moment. So I went on to say, okay, cool, I like this programming thing and creating programs, creating algorithms, which was fun. What I recommend is any particular word that you don't understand, just dig deep into it, Google that particular word. Say, for example, on this particular thing is the original formulation of a computing problem to executable computer programs. Programming involves activities such as analysis, developing understanding. Say, for example, you don't understand what analysis is, just Google that, have more depth into that. So I went there and said, okay, cool, because we have this nice thing called computer programming. I just wanted to find out that who was the first programmer in the world, and this lovely lady that I mentioned in the previous video was actually stipulated as the world first programmer, which is Ada Lovelance. By profession, she was a mathematician, but then how her work started was, as I mentioned on the previous video, she worked on Charles Babbage's research or whatever product that he derived, which was the difference engine or the calculating machine. So Ada Lovelance went into that and wrote a couple of algorithms on the analytical engine. So the analytical engine, what Ada Lovelance did was actually uh, compute manually numbers. Okay, cool. That's that particular series. Just Google what manually numbers are, and it will actually give you it will actually show you what the computation of the program was actually doing. So she did this while she was doing a couple of research on what Charles Babbage worked on, and found out that the analytical engine can actually do way more than simple computations. It could follow instructions, and that's what gave us computer programming. And today we do multiple things like apps, mobile apps, websites, and a lot games. We have a lot of programs that we actually use on a daily basis. YouTube itself, where you streaming this video, whatever host that you're streaming this video from, what I'm using to record these videos, bunch of all of these things that you see here is in essence programs. So that's that. And Ada Lovelance, because of the contribution that she has had into science or STEM, there's actually a day dedicated to her, which is the second Tuesday in October, where the STEM community actually calls it the Ada Lovelance Day, where they celebrate the contribution that she has made into what do you call the science space essentially. So cool. After that, then I wanted to find out what was the first computer program, and the first computer program, as mentioned on the previous or just now, it was a program that was coded by Ada Lovelance, and this is what it gave us out then, which was what you call executed on the analytical engine essentially. So what does programming mean? Previously from you call history, you find that they were using punch cards. So if you are not familiar with a punch card is essentially more like if you remember the VGA cards from the olden days. I think a lot of people who were born far later, they are used to USBs and streaming and all of that, so they don't actually know this VRC thing tapes that I'm talking about. But then what would happen is, think of it as on your ruler, you have multiple what do you call centimeters, so 1 to 30. So at each particular value, you'd expect either a hole, which is a punch, or you'd have what do you call a number representing. So the hole versus the number that you have on the what do you call on the ruler would represent a certain what do you call sequence of information, so to say. So that sequence translates into something else. So that's basically what they would use, what you call back in the days. So currently, what we use with the similar concept that I what you call explained, we use something called binary language. So binary language, what it means is a 0 and a 1. So as I mentioned on the ruler, where each number, you can either write a number or you can have a whole. So a whole will typically be a 0, where there's a number, that number will typically be a 1. So you'd either have a 1 or a 0, which is a binary. It's meant binary because it can represent two states. So that particular what you call whole represents something. If it's filled and it's not a whole, then it will represent something. Hence the word binary. So two representations in that what particular space. So that's that. Binary is actually stored in the computer central processing unit, and it is read or translated using a transistor. So think of this as what do you call, in terms of electronics, a transistor actually detects if there's current or not. So if it's a 0, what would happen is it would mean that there's no current. If there's a 1, it means that there's a current. So think of it as an open closed switch kind of approach. So that 0 and 1 represent different things. And that's what we get into when we talk about binary code. I think there's a couple of examples. Whenever you Google binary, you actually see ones and zeros. Let's see what this particular screenshot has. So cool. If you look at this, this is, let's say here, this is binary code. But then each bit here, let's say that's 0, that 1, that 0, that 0, that 0, that 0, that 0, and the final 1. Each of them, it's actually a binary. So a combination of them gives us a couple of things that we can look at. So say, for example, if you wanted to understand how your normal A, B, C, D to Z alphabets are actually written in binary, this is the actual representation. So we have them in capital letters here. You'd expect a different binary to actually represent them in what do you call smaller case and all of that. So that's what binary looks like essentially. And that's what the computer actually understands. So the computer doesn't store A, B, C, and D, but in essence stores this one a series of ones and zeros. So cool. That's that. Then here, I think I'll add this link, or you can actually Google more definitions around binary, how binary works. But then binary, as I mentioned, a space, think of it as a box. On each box, you would have, let me go back to this one. So think of this 0 here and this 1 and this 0 as 0, 0, 0 as box. What would happen in those boxes is you can have either a 1 or a 0 in each box, right? So each number here, this can either be a 0 or a 1. In this particular case, it's a 0. Similarly to this one here, it could have been a 0, but currently it's a 1. So that gives us two representations. So the number of outputs that you can have, depending on the number that you have here, it's 2 to the power of the number of binaries that you have here, which is in essence, in IT language, we call them bits. So this number here and this one and this one and this one, it's called a bit. So to know how many representations of a combination of bits you'd have, you'd say 2 to the power of that particular bit. So that's essentially what you have. Let me show you something here. Yes, this is the definition. One bit can only be used to represent two different values, so either a 0 or a 1. But then when we have two bits, it would be 0 1 0 1. So it could be 0 0, it could be 0 1, it could be 1 0, it could be 1 1, which gives us a total of 4 different permutations or results based on that. So that's basically what this paragraph is explaining there. And if you are keen on understanding more about this particular what you call binary numbers, which I recommend highly, check out something that you'd normally see if you install in programs, 32-bit versus 64-bit. Find out what it means, how it works, and all of that. So that's a basic definition of 32-bit operating systems or programs. So 64 bits would be 2 to the power of 64 in this particular case. Cool. Let's jump into a bit more. Okay, cool. Then we have another interesting dimension to this thing. The other dimension is, how does the computer actually know how to, use this particular set of binaries and interpret it as an A? What about people who use, let's say, for example, the Chinese language that has different characters compared to what we normally use on ASCII? So how does this particular numbers get translated? So we have two concepts there that is basically called ASCII. This is the ASCII table. Let's say, for example, the ASCII table there, it shows a decimal, the hex value, the character that you actually have there, but it doesn't show me. I wanted to see the binary and all that, but it doesn't show that. So you have ASCII, then you have something called Unicode. Those are encoding schemes, essentially, character encoding schemes. So if you look at that, it's a representation of numbers. Come on. It is a little bit better. I expected better. I don't know if it's network issues or what. Okay, cool. I see something. Okay, cool. Yeah, basically that's that. If you look at those particular encoding, that's Unicode. As an example of a Unicode, you have more or less these tables. This is character mapping, ASCII or what do you call? ASCII or Unicode. This you have it in Windows. I think there's a character mapping there in Windows. Just Google how to find a shortcut to actually have this thing, and it will give you the hex values, it will give you the binaries, and so forth, so forth. Cool. Then we jump into, now that we know that what is computer programming, who's the first programmer, what is what was the first what language does the computer understand in terms of binaries? Then we say, okay, cool, but people don't really write code with ones and zeros all the time. So they use a more understandable, user friendly type of languages. So I went on to say, what was the first programming language? So in the first programming language, what we found is that the first commercial, actually, to be accurate, is FORTRAN. So FORTRAN was the first commercial programming language. It was developed by this guy, John, who was working for IBM I think it was publicly released in 1956, but it was developed or created in 1954. Cool. Then after that, I was just like, okay, cool, let's go through a bit of history to see the most common languages that we use right now. And I bumped into this particular article on Wikipedia that details, more or less the history of this. And we can see that there's, let's say, for example, that FORTRAN language that we're talking about is there. You still have people programming in COBOL, also in FORTRAN. People still use it a lot in, let's say, for example, game development, because it's highly it's highly performant in those particular senses. Then we had that was FORTRAN. A couple of other languages came in. Most of the issues came about the languages have to be translated into which one was that? Let me just double check. Most of the languages basically need to convert the actual programming language into a machine code, and that's what actually took a lot of had a lot of computation issues. But the actual first programming language, which was developed in the 1920s, was known as the assembly language. There's still a lot of people who use that assembly language. They use it a lot for, as I mentioned, let's say game development, because that requires intense performance and all of that. Usually, people in those spaces would go for a language like assembly language to develop the game engines, essentially. Uh, why it was not used widely? It's because it required a lot to program in assembly. It's way more difficult or complex than the normal human readable programming languages. So I think that was that. Then cool. Or then this was, let me see this. Yeah, you see this is what I was getting to with shortcode. So shortcode was a language that was developed in early 50s. So it was proposed in 1949. So this language, because it was above what do you call? It was above the assembly language. So what happened was, because it had to be translated and all of that, performance issues. So hence why people didn't actually go for this programming languages which were human readable at that time. Because remember, computer resources were also limited back in the days. Excuse me. Cool. And yeah, that's basically that. If you look at those languages, Snowball, Basic, yeah, those are the couple of languages that we had in the 50s and late 60s, I'd say. Then we have Pascal on the 70s coming in. Then we have another language, C, that came in. C was renamed at some point into C++. So it was C with classes. I think that's what it was called. Then it was renamed actually to C++, because C didn't actually have a lot in terms of having object oriented type programming, which was a paradigm that came about after C was there. So C didn't have much in terms of the concept or the support of object oriented programming. And so I SQL there, used a lot for databases and all of that, analyzing data. I think that's a very useful language. Doesn't Well, you can create a lot of things with it, but usually people use it for databases and relational databases, to be precise. So there's what you call C++, which came in 1980. Cool. MATLAB used a lot in modeling in terms of the engineering side of things and all of that. Then cool. ASCII Python, actually 1990 there. Visual Basic supported by Microsoft, I think. Ruby came in as well. Ruby still fighting a very stable ground, and Python as well. But Ruby, I think it's fighting a very stable position currently with leading programming languages. It's also influencing a lot of the upcoming languages. They actually base them on Ruby a lot more. Ada 95, this I think it's a credit to Ada Lovelance as well. Java, leading in the market here and there. That was introduced in 1995. Delphi, JavaScript, we still use it heavily for web development. Then we have a flavor that says, let's say, TypeScript and all of that. There's a couple of JavaScript flavors that enable you to write, more object-oriented, let's say, JavaScript type of code. And cool, 2001, we get C#, one of the leading networks as well, programming languages as well, Groovy, Scala. Cool. Go, Rust, we're seeing a lot of Rust. Kotlin as well. Kotlin is a flavor of, Kotlin is a flavor of Java, but it removes a lot of overhead that we normally experience in Java. Then we have TypeScript, we have Swift. Cool. And yeah, that's basically the history in terms of this particular side of things. I hope this particular video was informative. If you want to learn more, as I mentioned, and how I'm going to conduct this particular series of videos is that I'm not going to create slides per se. I'm teaching something, what do you call, indirectly, that you can actually go to Google a bunch of this information, be inquisitive with your questions. Say, for example, as I mentioned on the first example, I can choose another one. If you wanted to, let's say, for example, you're reading this passage and you wanted to understand what this series actually looked like, you go to Google, as I mentioned, read about it, and you'll get a couple of information. If you want to know who Charles Babbage is, you go there. I want to know what the analytical engine is. Then they say the analytical engine was proposed mechanical general purpose computer. Mechanical general purpose computer designed by English mathematician and computer pioneer Charles Babbage. Okay, cool. I want to think that this is what the analytical engine looks like. Then we read that there was a difference engine and analytical engine. Then you can read there what the difference is between the two. Programming language. If you want to understand a couple of other programming languages, you could go there. Let me just say top 10 programming languages 2021. Just see. So there it is. I don't know who created this. That's statisticstimes.com. Never seen this report before. Okay, cool. My thing is blocking that. Then there's that one. Like Academy wrote an article there, let's say, for example, for languages to learn, and they have JavaScript. Chances are you'll find a lot of JavaScript because it powers a lot of web development. It is basically I think the leading framework that we use in terms of front ends. There's a couple of other flavors that we use, but I think JavaScript leads that particular path. jQueries and all of that, they are a flavor of JavaScript one way or the other. So JavaScript, Swift, that's used to develop a lot of Apple products, Scala as well, Go, okay, cool, Python. If you want to do, let's say, for example, a lot of machine learning and this gives you a lot of what you call tools or libraries to help you with that. Elm, Ruby, C Sharp there, Rust, good time. Okay, I'm hoping that's what do you call, that's the last. And yeah, that's basically how I go about creating these videos. Just a lot of Google. I hope you'll do the same, and thank you very much for tuning in. Please take note that I'm using this series is to actually improve my articulation, my communication skills as well. So if you have any recommendations that you'd like to share with me, if you want me to restructure this thing a little bit, just let me know so that I can also improve on my side. I hope this was informative. Have a good one. Thank you.